Okay, class, this is a short explanation for topic 4, vectors addition, and we'll focus on the analytical method because there are two ways to add vectors, the graphical one and the analytical method. So we will work on this last method. First of all, we will check some of the concepts or terms related to this part of the topic. We have vector that we know is described by magnitude, direction, and sense, like force, displacement, velocity, gravity. Resultant vector, which is the sum of different vectors, and it could represent total displacement, net or total force, resultant force. The component in X means a vector going towards east or west. It means to the right, to the left. Or component in Y, which is a vector towards north or south. That means going upward, downward. And these are the formulas we're going to use in this part of the topic. In this explanation, we have trigonometric formula, sine, cosine, tangent. Then we have the Pythagorean theorem with different labels. This is the Pythagorean theorem, and you can write it down in your notebook or look for them in Blackboard. Okay, this is the example we saw in class. When we have a vector and we're supposed to determine the components of in x and y axis of that vector. Like this, we have the Cartesian plane, and we have in yellow we have the vector. And we can decompose this vector into the components in x and y. You can see the vectors in green. If we trace a parallel line to the x-axis, we can make a triangle. The angle will be here. So, in order to get the components in x and y, we have to use the rectangle triangle method. Okay, as we did it in class, we have to apply sine and cosine formulas in order to get the opposite and adjacent sides. It means the components in y and x. Like this example. Determine the components in x and y of a vector whose magnitude is 50 miles per hour and it makes an angle of 60 degrees with a negative x-axis. So we have the 60 degrees that is formed between the vector and the negative x-axis. And this is the magnitude of the vector 50 miles per hour. Okay, first of all, we have to write the formula we're going to use. First, the component for x-axis. Vx is equal to v times cosine of theta. Okay, I'm using v because I named this vector as vector v. Okay, but remember that an angle should be measured from the positive side of the x-axis to the vector. Okay, in this way. So actually, the real angle for this vector is not 60 degrees. It's actually 120. Okay. So if we substitute this in our formula, we have that a component in x is equal to 50 because it's the magnitude times cosine of 120. Okay, if you check in your calculator, you will get these two factors, and if you multiply them, you will get minus 25. Don't miss the units. We were talking about miles per hour, so here we have to have miles per hour. And we will do the same for the component in y. Okay, Vy will be equal to v times sine of theta, and then we have that Vy is equal to 50 because it's the magnitude times of sine of 120. If you check in the calculator, you will get these two factors, and if you multiply them, you will get 43. And don't forget to write the units, miles per hour. So this is a way to get the component in x and component in y of a vector. Now this is a case included in topic 4 or unit 4, and it's when we have two or more vectors and we have to determine the components in x and y, and we have to determine also the resultant vector. It means magnitude and direction. Like this is a system of two vectors. It could be more than two, but here we have two vectors, the one in yellow and the one in green. And remember that we are focused on the analytical method. We have to use sine cosine in order to get the components, as a previous example, and the Pythagorean theorem to get the magnitude of the resultant vector, and tangent formula to get the direction. And let's have an example. We have to determine the resultant vector from the following figure. We have here the Cartesian plane. We have two vectors, 35 Newton is a vector in green, 20 Newton is the magnitude of the vector in yellow, and here we have the two angles. Remember, an angle should be measured from the positive side of the x-axis to the vector. So instead of having 50 degrees for the vector in yellow, we have 230 degrees. Okay? And we will make a chart like this. Just we have different columns. We have vector, magnitude, angle, sense, component in x and component in y with their formulas. So I will name the vector in green vector A, and the vector in yellow will be vector B. So we have vector A and vector B. Now, the magnitude for vector A is 35 Newton. Its angle is 70 degrees. Its sense, check. This vector, vector A, is going to the north, but also to the east. So it's northeast. The component in x will be equal to component in x of vector A is equal to 35 because it's the magnitude of the vector times cosine of 70. Okay? And this will give you 11.97. We will do the same for component in y. Okay, the component in y of vector A will be equal to 35, which is the magnitude of vector A, the magnitude, times sine of theta, in this case theta is equal to 70. This will give you 32.89. We will do the same procedure for vector B. The magnitude is 20 Newton, the angle is 230 degrees, and the sense is southwest. Check that vector B is going to the south and to the west. The component in x will be equal to 20, because 20 is the magnitude of vector B, times cosine of 230, and this will give you minus 12.86. Doing the same for component in y, we have 20 times sine of 230, and this will give you minus 15.32. Check the signs of the components, okay? Ax and ay, components in x and y for vector A, both are positive. It makes sense because vector A is located in the first quadrant, so check. Here is between the positive side of the x-axis and the positive side of the y-axis. That's why both are positive. Now, vector B. Vector B is located between the negative side of the x-axis, that's why bx is negative, and the negative side of the y-axis, that's why by is negative too. Now we will get the resultant vector. In order to get the resultant vector, first we will sum, okay, or we will add the components in x for vector A and B, and then we will sum the components in y for vector A and B too. Okay, so we have 11.97 plus minus 12.86. This will give you minus 0.89. If we do the same for the component in y, we will have 32.89 plus minus 15.32. Now we will represent these two components in a new Cartesian plane. We could draw these components in the same Cartesian plane, in the original one, but I will use a different plane in order to make it clear for you. So we have that Vx is negative. Okay, so I will trace this component of this vector in the negative side of the x-axis. Now Vy is positive, that's why I will trace this vector or this component in the positive side of the y-axis. That means that the resultant vector should be located between these two components. And we can get the sense, okay, of the resultant vector. We can determine the sense. It means this vector is going to the north and to the west. So the sense is northwest. Okay? So here I label all these components. Vx is the adjacent side, Vy is the opposite side, is represented by this parallel line, okay? And Vr is the resultant vector, okay? And then we will use the Pythagorean theorem in order to get the magnitude of the resultant vector. And according to the labels we have, instead of CAV, we will use VR, which is the hypotenuse, VX, which is the adjacent side because it's next to the angle, and By, that is in front of the angle, this is the opposite side, okay? So if you substitute these two values, Vx and Vy, here in the formula, and then you raise it to the second power, and then you take the square root, I mean, if you leave alone the resultant vector, you will get this value, 17.59. So this is the magnitude of the resultant vector. So I will write this number in the magnitude column. Newton, because we were talking about Newton, okay? Now, the angle is missing. In order to get the angle, we have to use the tangent formula. You know that tangent of data is equal to opposite side over adjacent side. But remember, we're not talking about opposite and adjacent side. We're talking about opposite, Vy, or this Vy, adjacent, Vx. Okay? So I will use those terms, Vy, Vx. Now, we need to leave alone data. So we need to get rid of tangent. Okay, in order to get rid of tangent, we need to use the inverse function of tangent. In this case, will be inverse tangent. Okay, so we will have that data is equal to inverse tangent of Vy over Vx. And if we substitute the values here, we will get that data is equal to minus 87.1. Now, why minus 87.1? Remember that this angle is actually this, the angle between the vector and the negative x-axis. But an angle should be measured from the positive side of the x-axis to the vector. Okay? So, if we subtract, we will get that data is actually equal to 92.1 degrees. And I will write the value in the column. And that's it. This is the analytical method. In this case, we use only two vectors, a system of two vectors, but it could be more than two, and the procedure is exactly the same.